All right. So today is the SI session for September 8th. So just like last time, changing your name in Zoom or typing in chat is how I will make sure that you get your extra credit. Just as long as it matches what your name is on Canvas, then we are all set. So go ahead and do that when you get a chance. So what I was thinking about covering today was talking a little bit about your textbook, how that works, some of the assignments that you'll see in it and how to complete those. If none of you completed the quiz from the last SI session, I threw it in here just in case we wanted to do that. Then I'll talk about debugging, which is basically what happens constantly to programmers when you mess something up in your code, which is always going to happen. Well, not always, but very frequently, and some tips and tricks of how to do that. We'll briefly review input streams, and then we'll talk about making a calculator program that will take two inputs from a user and then add, subtract, divide, or multiply them. And I'll have you guys help me out with that. All right, so for your textbook, Zybooks, what you're going to want to do when you start an assignment for Zybook is you're not going to want to go directly to the website like this. This is what you're not going to want to do, because you can complete your assignment like this, but it's not going to go to Canvas for your grade. So you will complete it, but not necessarily get the credit. Instead, you're going to want to go to Canvas. Then you're going to click on Steve's course right here. I'll put this in student view, so it's how you guys see it. And then you'll go to assignments. And then from here, there's chapter 1, which is the one that's coming up that you're going to want to start working on pretty soon. It's a big reading, but it's not terrible. And then you're going to load chapter 1 in a new window. I'm going to have to leave student view so it actually recognizes as me. So I'm loading chapter 1 in a new window. And now Zybooks and Canvas are connected with another. So when you're completing the little assignments that I have within the book, it will actually update in Canvas so you get the correct grade. So just remember, for every single chapter that you do, and when you like restart your browser and want to go back and complete whatever you didn't finish, go ahead and make sure you click that button that I clicked earlier. All right, so your textbook, what you're going to be doing before September 19th is everything in chapter 1, introduction. So it will have some sections which are just reading, and then some of them you'll have to do some multiple choice answers after. So I'll click on this one called errors because it's kind of related to something that I'm going to talk about today. And you'll start off by reading what is happening in the beginning. They'll give you some definitions on what a syntax error is versus a compiler time error, and you'll learn all about what that is. Then they have some examples here that are going to just be interactive where you can run them. And it's making a point here saying, okay, this is an error that you could receive when you run this program, and it's going to point out what's happening, and then you can go in and fix it and run it again. So you can edit this to run and rerun, and it's just like your regular text editor. And then you have 3 of those. There's some where you have to type stuff out. So it says for each of the code fragments below, type OK if there's no error, or else correct it. This one is OK, everything's good, and this one you can correct it like that. But if I did mess it up like this, it's going to give me a suggestion of what's going on that I might want to fix, and I can go in and fix it, and you'll still get full credit. So don't worry about getting correct on the first time. That doesn't matter. Just keep trying until you get it. And that is that. Then there's multiple choice. Again, doesn't matter if you get it wrong the first time. I can go in again and click the correct one. That's just a little bit of the textbook just to clarify what you can and can't do regarding wrong answers. The wrong answers are all good. Just go in and fix them, and make sure to click through Canvas. All right, someone else joined. Hello, welcome. I did want to let you know that in order for me to give you credit for SI, change your name in Zoom to the name that you have on Canvas, or type your full name in chat. That way I can make sure you get your extra credit. And thanks so much for joining. So we just covered a little bit about what Zybooks is, and just make sure that when you, awesome, thank you so much. When you are using Zybooks and you want to start your assignment, this is the key point that I wanted to make. You have to go to assignments And then from there, you're going to find the chapter that we want to look at. Then make sure you click this load chapter in a new window, and then you can start doing your assignment. Otherwise, your points won't get translated from Zybooks to Canvas. All right, any questions on your textbook that you want me to answer before you guys get started on your assignments coming up? All right, and as always, please interrupt me if anything is confusing or you want to ask anything. All right, so did anyone do the quiz that I made in Canvas? Because if not, I figured I would do it with you guys and we can all look at it and answer. I don't want to make anyone do it twice. All right, stop me if anyone has done it, but if not, what I'm going to do is I'm going to go to my SI page and put you guys in student view. All right, so last SI session, I made a very short quiz, just 9 questions. It's ungraded, you don't have to do it. This is just a tool that I'll use sometimes to help you guys prep for exams and test what you know. So let's go ahead and get started with that. So in chat, you guys could just type A, B, C, and D. And you can type this privately or publicly of what you think the answer to question 1 is. So question 1 is, which of the libraries do we need to include for the value XXX? So basically whatever we see here is going to get interchanged with that for using standard input and output. So this is when the user is entering information or when you're giving information back. Which of the libraries is it? All right, someone said A, and A would be correct. A is the library that you're going to include in every single one of your programs this semester that use input and output, which will generally be every single one of them. And good job. All right, which command allows you to see all non-hidden files and directories in a given location? So if I were to type this command in the command line, all my files would and directories in that location would come back and I'd be able to see kind of where I am. All right, someone says C, and C is correct. Good job. It is the ls command. I like to call it list stuff, just in my mind so I know what's happening. And very nice. All right, what is a comment? It's actually something new from Steve's class today. All right, we have B. And B is the correct answer. Comments are completely ignored by the computer. Computer does not care what you put in a comment. It's just a way for you to leave notes for yourself or any other people who will be reading your program. All right, this is like the example from yesterday. So I have a file, hello.cpp, at this location. How am I going to run it if I am standing in this directory? All right, someone says A and someone says B. All right, 2 very good answers. I made this one a little bit tricky. So we're going to look at A and B and compare what's different. So we're standing in the tilde directory, which is the same as home, which we learned was the combination of the root user and the person using the computer. So that's where I am right now. So that takes care of this. So we need to move to documents, then to SI for fall 2022, then the codes, then to what was today's date, which is now in the past. But both of these do that. We did the CV command, then we went to documents, then we did all the subsequent locations that we need to go. So the next thing is we're going to compile the program. So when we compile the program, it's actually G++. It's not C++. A little bit weird, but the compiler that we use is called G++. And when we compile the program, that takes our code, checks it, makes sure everything is okay regarding the language. And if so, it will create something called a.out or a.exe. And then to run that, we use / and the executable name. So the correct answer here is A, but B was very, very close. So good job to both of you. All right. And just to clarify where the other 2 went wrong, we can't put the file name at the end of our directions. because we have to end in a directory. We're navigating 2 directories and then we run the file. And this one is not correct because we're using a compiler on an executable. All right, good job. Next up, C++ lines generally end in what? All right. And I have one person saying C, and C is indeed the correct answer. It actually should say statements here. I kind of messed up, but C++, when you're ending a statement, you're going to end it in a semicolon almost all the time. It's kind of like the period of C++, how we end sentences in a period. When we're ending a statement in C++, it is a semicolon. All right, a programmer wrote the code, hello world, end all, and they got some errors back. How could they have written this statement correctly? And you're going to assume that all other lines are correct and necessary libraries have been included. So like IOStream is there, using namespace SDB is there, int main exists, all that stuff exists. We're just focusing on this one line. And if it is correct, we'll just write okay, kind of like the book did. Yes, someone says that it needs a semicolon at the end. This is correct. We just talked about how C++ statements need a semicolon. So we're going to do cout because that is our output stream, standing for characters out. Then we have our insertion operator, our string literal hello world. And then we have endl and a semicolon. Now, is this correct as is? Or does it need any more editing? All right, it is almost good. It's very, very close. So in C++, our cout statements are separated by these insertion operators. So every piece of our cout statement is separated by these. So we have one here, it goes cout, then we have our insertion operators, then we have our string literal, but then we have endl over here. And endl actually needs to be separated from hello world. It's a different piece of the statement. So you'll get a hang of this as you go on with cout statements, what needs to be separated and what doesn't. But we definitely need these in between or we would get some errors. Now it is correct. So good job, you guys. All right. And interject if you have any questions. We have 3 more of these left, and then we will move on. A, B, C, and D. Programmer wants to store the number 1,889 in a variable. What is the best data type? So multiple of these will work, but which do you think might be a good idea? All right, someone is saying A, and A would be the correct answer here. So why the other ones are wrong? Well, not necessarily wrong, just maybe not the best idea. String we saw yesterday can be used because it is a series of characters right here. However, we wouldn't be able to perform any math on this because it would no longer see it as a number. Char, that's not really going to work because remember characters, when we put them in single quotes, it had to only be one thing here. It can't be like A, B, C. It's just one thing. So char doesn't work. Double, it could technically work. And this is something that we will get into later in the semester. But think about this. In the beginning of one of the classes, Steve was talking about binary, right? And how everything in our computer is in bits. So 0s and 1s, right? 0s and 1s can represent numbers, but they have a hard time representing a decimal. So this number, I'm not going to try and calculate it right now because that would take too long, but we know that this is 1, this is 2, this is 3. So these are all whole numbers, right? When the compiler is trying to store a double, a fractional thing, it can't technically. It can't store it exactly. So doubles are very inaccurate, but they have their purpose. So the point of what I'm trying to say here is when we can store the number in an integer, we're going to try and do that. But doubles have their purpose, so don't be scared of them. All right, so int is the correct answer. All righty, we're going to create a variable called rClass.
Can I ask a question?
Of course, go for it.
Sorry. So back to this number 7.
Okay.
Does that relate to what we were talking about today in class about he was using like the spaces like 17, 18, and 19?
Kind of
Um,
like with the inputs.
Yes. Yeah.
Kind of. So are you referring to how doubles aren't stored accurately or the data types themselves?
The data types themselves.
Yes. So the data types themselves, when we will create a variable to store input in, we need to make sure that the data type of that variable that we're about to put input in is the data type of the input. So when he's typing 17 into the input stream, we want to make sure that the variable that is about to store this 17 is an int. We don't want it to be a char. We don't want it to be a string. We really don't want it to be a double. So when we type 17 into the terminal, the variable that this 17 is going to get stored in should have a data type of int. So that's what variables are used for. They're used for storage of information, which is sometimes user input. So
Thank you.
yeah, of course. All right, and we'll see more examples of taking input for numbers today when we do the calculator program, and that will hopefully clarify a lot. Okay, so we need to create a variable. Oh, here we go. Here's another example of a variable called our class with the value CS-11. So I have 3 boxes here. What do you think goes in the first box?
CS-11.
All right, so C right here. All right, so first box is CS-11. What is in the subsequent boxes? And I could remind you the structure of a variable declaration if that helps. So when we're creating a variable, this means that it didn't exist before and we need to establish that it exists. The syntax is data type followed by name. And then we can put a assignment to it when we create it if we want to. And this is going to be the value that it is assigned. So, and this is 1 per box. And a semicolon as usual. So what do we think the data type is?
Would our class go in the name?
Our
Or
class?
is that even part of like, okay.
No, you're absolutely correct.
Okay.
Our class is the name. That's how we're going to refer to our variable in the future. So perfect. All right, so that's 1. We've got this one. What do you think goes here?
Would it be the data, what's in data type box and name all together in the end?
Like this?
Yes, that's what I'm guessing.
All right, we are close. So you have 1 part correct. This is 100% correct. This is our identifier. This is how we will refer to our variable in the future. So if you want to think like math variables, you have X, Y, Z. The X or the Y itself would be how you're going to, what you're calling your variable. So in C++, instead of naming things, kind of boring names like we do in math, X, Y, Z, alpha, beta, whatever, we get to actually make full names for them. So when we reference it later, it tells us quite a bit. So that is good. That is correct. The data type specifies what type of data is getting stored in our variable. So we saw a few of these up here. These are the ones that you've learned so far. We have int, double, char, and string. So when we think about our variable, our class, what are we wanting it to store? So we have a box named our class. What do we want to put inside of it? What should it store for later? Well, it's going to store the value CS-11. Our class is CS-11, so that's what we're going to want to store. So CS-11 is what we're storing. What data type is this? Yeah, there you go. Someone got it in chat. This is a string because strings are a series of characters, and that's exactly what this is. Strings are text, they're words. They're this is a string. This, wait, no, that's a bad example because that's actually the name of our variable. This is all strings. Strings are just text, they're words, they're letters, they're combinations of letters and numbers. It is just text. So that is the correct answer here. So it's a string. So we are very, very close. We have the data type. The data type defines what we are storing. We have the name. The name defines how we're going to refer to our variable in the future when we want to use it. And then we have the value. And the value is what our variable is storing. So CS-11 is what we want to store. We just want to make sure that we put it in double quotes, because whenever we use the string data type, we are putting it in double quotes. So think like your hello world statement up here. This right here is a string. It's text, right? It's text. But notice that we put it in double quotes, and this is what defines a string. So we just need to make sure that when we use strings, literally, they're called string literals when you write it like this, when they're not inside of a variable yet. You put double quotes around it, and that defines it as a string. So this would be the correct answer here. All right, last question. A, B, C, D, and E. Which of the following are valid identifiers? An identifier is basically the technical programming term for name. So this is something that we covered in SI yesterday. So if you weren't here yesterday, this might not make too much sense to you, but I'll recover it very briefly after we get this answered. So this is what is valid that you can go in this spot without the compiler complaining. And this is a tricky one, so maybe I'll help you guys out. All right. Oh, we got one in chat for D. D is correct. D is a valid identifier. And the reason being, the specification for what an identifier can be, the name of our variable right here, it can be a series of letters. It can be underscores. So that's this character, or it can be numbers. However, the numbers, we have a little caveat to them. The number cannot be the first character in our name. So not, okay, so now that we know that, let's see. This one is invalid. And the reason is we have this at symbol, right? We can't use that. It's not a letter, it's not an underscore, and it's not a number. So A is invalid. B is also invalid because we have num and we have one, but there's a space in between them. Spaces are not letters, underscores, or numbers. So this one is out. This one, C, we have letters and we have numbers. However, the number is in the first spot. So this one is not valid either. Finally, we have E, num underscore one. We have num, which is letters, underscore, that's valid, and one. So this one works too. And yeah, any questions on this last part here? It's just what can we name our variables? Or anything in this? If not, I'm going to go ahead and submit, and hopefully my grading system all worked. Correct. All right, awesome. That is all working. Any questions on that?
Will this, I wasn't here the other day, but will this be up for throughout like the whole semester to like practice on?
Yeah, for sure. I'm planning on making quite a few of these over the semester just to review new stuff you've learned. And before every midterm and final, we'll have like a really long one with like 30 questions that are very similar to Steve's exams because I actually get to see them. So this is kind of just like prep. So your exam questions will honestly look very similar to this. We'll have some fill in the blanks like this. Steve really likes those. You'll have multiple choice. You'll have a few very short answers where you're writing just like a snippet of code like this. But yes, to answer your question, this will be available throughout the entire semester, and you have unlimited attempts. There's no due date. Yeah. So take it as much as you want, and you'll get instant feedback for all of them. All right, so that is that quiz. So we have done that. The next thing that I want to talk to you guys about is debugging. So you're writing more and more programs now. One thing that you're going to run into is when your program does not work, and how do we handle that? So when we're programming, there's two different types of errors. You don't really need to know which is which by name, but they're good to just have defined as a programmer. So syntax errors are errors in like the grammar of the way your code is formatted. We saw one of those earlier in the quiz where I wrote C out and didn't have a semicolon. That's a syntax error because C++ defines your statements to end in semicolons. And we did not put a semicolon. So this is something that the compiler will pick up on. This is when you'll get an error or a warning from your compiler, and it'll tell you, hey, something's wrong, please go fix it. They're also called compiler time errors. It means at the time of compiling, you had an error. So these can be missing semicolons, as I just mentioned, an incorrectly spelled variable name, if you chose the wrong type of variable, if you missed these extraction operators, those are all syntax errors because it's an error in the way your code is written. These ones, we don't mind too much. They're not terrible to solve. However, logic errors are ones the compiler will not pick up on. Logic errors are technically known as bugs, and these are ones where the programmer themselves makes a mistake in the logic of the code. So maybe we have a cout statement, and we have some text right here, and we say 1 plus 3 equals 7. And then we had ENDL and a semicolon at the end. Well, as far as your language is concerned and the compiler, it doesn't care. It sees this as all perfectly fine C++ codes. It sees the cout, sees the extraction operators, the string is enclosed in these quotes, and we have an endl and a semicolon. It sees this and it thinks it is perfect. However, we made a mistake because 3 plus 1 is definitely not 7. So this is a logic error. It's when the programmer themselves makes a mistake in how the logic of the code should function. Those are a little bit harder to find, and you'll get used to those. So now that I've just gone over the technical stuff, we are going to look at a code that I have definitely messed up very, very well. And you guys are going to help me fix it. So the first thing that we should do when we are debugging is run the program. So I'm going to navigate to where I have my program saved. So it's on my desktop. I just know this, and it's under codes for SI. And when I list my stuff, I can see debug original is right here. So that is what we're going to want to go and run. So I'm going to use the G++ command followed by debug original. And we have some errors back. So these are our compile time errors, right? Because the compiler found them. So what is this? When we're looking at a series of errors, we always look at the first one. We don't look at these ones. These ones in your mind should not exist. They might be valid or they might not, because what happens in your program, if you remember, it goes from the first line, then to the second line, then to the third line, fourth line. It's going down in sequential order. So if it got confused on line 1, everything else in your program might not make sense to it anymore. So when we look at errors, we always look at the very first one that's given, and we solve that, and then we recompile and see the rest of them. So how errors in C++ are written is that a format. First thing here is the file that, where's my pencil? This is a file that it's coming from. And then this part right here, the 1:10, this defines the line number followed by the character number that it got upset. So what line do you think is this coming from? This is line 1. When we go to our program, we're going to look at line 1. And then it gives us a little bit more information. It says expected file name or file name. One is in quotes, one is in brackets. How could I fix this line 1?
You said it was one was in quotes and one was in brackets.
Yeah, so in the error that it shows you guys here is saying expected file name or file name. So one of these is in quotes and one of these is in brackets. You guys haven't learned the quotes one yet. So it's basically saying that your files that we include at the top of your program have to be in angle brackets like this. That look a little bit better?
Yes.
Yeah, there we go. So let me get rid of these squiggles. They aren't deleting for me. Okay, there we go. And now that we have this error solved, what we're going to do is we're going to save and we recompile. All right, so notice that that first error is gone now. We took care of it. Now it's complaining that we need a semicolon at the end of this line. This error is pretty clear, right? It's saying there's a semicolon and it's needed. It's actually pointing to it. So that's great. So we're going to put in our semicolon. And if you guys see anything else wrong with this line, let me know. If not, I'm going to recompile. All right, so it's still complaining about this line 2. Anyone know what's wrong? Well, the answer is it's telling us expected namespace name. So we say using namespace, the correct terminology for the namespace that we're including. Don't worry about what a namespace is. You won't need to know this for the entire class. All you need to know is this line is written as using namespace std. In C++, we shorten standard to std. All right, and now we save and we run. Oh, did I not save? I saved the terminal, didn't I? Okay, there we go. All right, we have another error on line 4. Does anyone see anything wrong with line 4? Yep, exactly. I need the parentheses right here at the end of main. So main is a block. That's all you need to worry about. It's where all your code goes and is written as int main and needs some parentheses at the end. You'll learn what that is later. And then it starts with an open curly brace, which starts the block. And then we'll need a curly brace at the end to end the block, because everything that we're writing programming wise is going inside of this box for now. This will change later on the semester, but for now, all of my lines are going to go between this curly brace and this curly brace. I should not be writing stuff down here. All right, cool. Let's save and run that. Okay, now we have a whole list of them, and I'm going to scroll. Wait, I'm gonna make some room so I can see which errors are coming from where. I'm gonna just make a few more lines. All right.
Before we move on to the next one or the next lines, back to standard or line 2. So what was wrong with it? The computer wouldn't take the whole written out word. It just takes that initial.
Correct. So this is kind of like an official naming of something. So somewhere in the language, they defined this line to be written as namespace std. They wrote it this way because it's a shortened version, and later on in your programs, you're going to be writing this a lot, not in this semester, but they didn't want to have to type standard every single time. It was getting too long. So they shortened it to std, but it's a specific name of something. So just like if I were to run my file, I can't call this debug like this, debug, and expect it to know what it is, right? It's not going to know what this is. It's going to say, I don't know this file. It's because I didn't use the full name of original. I have to spell it out. It's kind of like that. It's the name of the thing, and you just need to call it the correct name or it doesn't know what's happening. Does that answer that by chance?
Yes, it does. Thank you.
Awesome, of course. Okay, so back to debug original, spelled correctly this time. And we have this error right here. What's wrong?
Is it the data type?
Or
Is it, or I'm kind of referring back to like the quiz when we did like
Yeah,
number.
yeah. So you're close. It is definitely with this. So remember the syntax for this. It's data type, name, and it's assigned with value. And the data type and the value have to correspond to each other, right? Whatever the value is, it has to be this data type. So what's our value in this case?
5.
Exactly. So 5 is your value. So what data type is 5? And if you don't know, it's okay. We just started these variable things. It's going to take a long time to get them down. So 5 is a number here. And numbers, when they don't have decimal places at the end, when it's not that, they're integers. So here's another thing where they decided to shorten the name. So this is technically called an integer, just like this is technically called standard. They just shortened it because you're writing it so much that it's a pain to type integer. So this is correct. Int is indeed correct because 5 is an integer. Let's take a look about what it's complaining about. It says expected unqualified ID. And I'm going to tell you guys that ID means identifier. And then right here, it's pointing. It's pointing at the name. It's saying that something is wrong with 5-day. And someone got it in private chat. You are absolutely correct. The name cannot start with a number. We could have switched it to day 5, and this is fine. However, 5 in the beginning is not okay. And you can actually notice BB Edit is highlighting that 5 differently because it's not recognizing that 5 should be a part of the data type, the name. It's thinking that this is just a random 5 floating around the program because the law says no numbers in the beginning. But if we put it at the end, then we're good. So I'm going to just remove it entirely because it's kind of useless. All right. And saving and recompiling. First error. All right, this is a nice and easy one. It's very descriptive. It's telling us that we expect a semicolon at the end of our declaration, and it points at the end of it and it says semicolon must go here. All right, cool. And now we fix whatever is happening in my terminal. And nope. Bad, don't do that. Okay, there we go. This one is not as descriptive. It's telling me that I need a semicolon. However, I have one. I definitely have a semicolon at the end there. So sometimes you'll get very nice errors like the one that we just saw, where it literally will use the green arrow and point and say, you need this here. And sometimes it will be like this, and it'll say, you need a semicolon here, where we know that a semicolon definitely does not go here. So we were lucky and we got the correct line number. We know the line's on problem 7. I mean, the problem is on line 7, but it's not being very descriptive. And this is just a fault of the compiler. They can't know everything. So we're going to have to look at this and decipher what is happening. So what do we think is wrong here? Yes, we are missing the equals, because what the equals does in C++ is it takes whatever is here on the right side of the equal sign. It takes it and it assigns it to whatever is on the right. So it's taking our value, which is 0, 9, and it's going to store it in months. So it's taking this and it's putting it over here, which is exactly what we wanted to happen. We wanted the month to be 9, so September. All right, anything else wrong with this? Saying that we're having a little bit more problems here. And I'm going to tell you guys that this warning here is not super helpful because it's all in technical terms. So what we need to notice is what we have here is a character, right? However, characters are different than strings. character is a single letter, or it's a single number. Oh, that's not double quotes. 9, or a single symbol. It's just one. We can't have two. So we could either switch this data type to string, we could make it an int and delete b quotes, or we can just delete the 0 in front of the 9. So any of those fixes will work depending on what we're aiming for here. So which one do you guys like?
So if we just put 9, that's fine.
Like this?
Yes, I
Yes.
think.
This would work because we have a data type named char, and we are assigning it the value of 9. The 9 is in single quotes, and single quotes define characters, just like double quotes will define strings. So this is all good. And yes, this will make it a 9. The only thing here, it is not an integer, which is something we don't care about. So we can't do this plus 1, but we can do 9 plus 1. It's dependent on what data type it is. So it recognizes this as a number. It recognizes this as just some text. Even though they are, to us, both technically numbers, in the compiler, when we put the quotes around it, it sees, oh, this is just some text. So it doesn't really care if this were a 9 or if it's a B or an A. It sees it as text no matter what. And when we say A plus 1, it does actually have application, but it's not going to do what you think. So if we're doing arithmetic, make it an int. If you don't care what's happening and we don't have to add anything, it doesn't matter. So yes, this would work. Okay. And moving down. All right, we are done with line 7. We are at the final step, which is our cout statements. So it is complaining that we are missing a semicolon in the middle of our cout statement. And we know that that is not true because we have one at the end and our statements end in semicolons. They don't appear in the middle like this. So what are we missing here?
Are we missing the less than?
You're absolutely correct. Yes, we are missing the less than symbols in between because this is a piece of the cout statement, and so is this, and so is this. Like, this is a variable. This is a literal character. They're different. They're not the same thing. So we separate them, or all these different pieces, they're all separated by these insertion operators, fancy technical term that you don't need to know. And yes, that would be the correct fix. And you'll learn as you write more and more cout statements where those need to go. Okie dokie. And that is a lot of errors. So we're scrolling all the way up to the top and we're not going to get scared of it. Okay, so invalid. Okay, it's complaining about the cout statement. I'm going to tell you that this message means nothing to us. This is just a compiler not understanding what's happening. Wait, did I not save? I'm going to recompile just to make sure. That looks very familiar. Let's see. Okay. This looks a lot better. All right. Again, this message means nothing to us, but it is giving us a nice little point at something. Is there anything wrong with this?
Are we missing the owl? I think that's what it.
That is correct. 2 of you guys got it. Awesome. So we are missing the L in end L. It stands for end line. So we can remember the end, the L needs to be there because what it's doing is it's ending off our line. Perfect. All right. So getting rid of some extra space here. All right. Look at this. This is a nice little arrow to finish off on. Return 0, need the semicolon because it's the end of a statement. And there we go. No errors. When we get nothing back from the compiler, when we run this, that means that all of our program is syntactically correct. We have no more syntax errors that are being picked up by the compiler. So we are set to run it. So it says today's date is September 5th. The compiler didn't tell me that this was wrong. what is this an example of? Because today is the 8th. Compiler didn't tell me that this was wrong. This is an example of a logic error. So when I was programming this, I intentionally made it so the day was incorrect so you guys could see that your compiler is not going to pick up on things like this. If we misspell date like this, compiler doesn't care. It sees this all as correct C++ code, and it's going to just output whatever you tell it to. So this is a logic error. They are hard to find sometimes. Luckily, this one is nice and easy. We just change the 5 to an 8. We save it, and we run it. And there's your one nice thing about variables. If we use the day like many, many, many times in our program, so say we wanted to see out day again, and for whatever reason, we wanted to see out it again, like this. That would be a mistake. And I were to run this, everywhere that day appears in my program, it has the value 8. Well, say we traveled into the future and now we're at the 9th. If I were to rerun my program, I don't have to change every single occurrence of where I decided to use 9. I just have to change where I assign day with the value 9, and every later occurrence of where I use it is going to get changed. So that's a kind of cool feature about variables I thought I'd point out. And now this code is all correct. So very nice job. Any questions on that? Let's see. What does return 0 do? All right, so return 0 is a thing that you will see at the very end of your main block. It should be the very last thing before the ending curly brace. And what it does is your compiler is going to go down these lines, right? They're going to go one by one. The first thing we're going to do is we're going to create a variable named year. Then we're going to create a variable named day. Then we're going to create a variable named month. And we're just going down in sequential order. Then we're going to do a cout statement. And then we hit this return 0. It's the last thing that the program sees. And basically what the return 0 tells your computer is if I hit this return 0 line, that means that everything else ran correctly. I didn't stop in the middle and say, wait, cout is spelled incorrectly, because if I hit this line, it's going to cause an error, right? It doesn't know what this is. So it's going to exit the program and give us some errors. What return 0 says is if I run into return 0, that means that the program ran okay. So that's why we have that there. It like ends your program and it tells the operating system, yes, my program ran. All right. All right, cool. Hopefully that clarified that. So we are at 3 o'clock, so I don't think we are going to get to the calculator program, but I'll just give you guys a few tips on how to avoid bugs and errors. So the very, very, very most important step is to compile it frequently. Don't go writing like 50 lines of code and then do your G++ command and expect everything to come back okay, because that is very, very rare. So if we were writing this program, I would not have, besides for this example, I would not have written all of this in one go. Maybe I'd start by just compiling this and seeing that everything came back okay. And then I'd be like, cool, that worked. And then maybe I'd add in my variables, or maybe one variable at a time, even if you aren't comfortable with variables yet. And then I would save it and I'd compile it and nothing came back. And then finally, I'd add my cout statement, and then I would save and compile. And I just do this in little tiny pieces like this. That way, if you do run into an error, it's easy to deduce where the error came from. So if I added the cout statement and everything else previously was running fine, I know where my error came from. It came from the cout statement. So then I can look at that and figure out what's wrong. Don't write all your code in one go. That is pretty much the same thing as before. When an error message comes up, don't ignore it. It's not going to magically disappear. Address the first error on the list first and then recompile. I showed you guys how we were doing that earlier. and then use your resources. You guys can contact me, you can contact Steve, you can look in Zybooks. If you're having errors and you can't really figure them out, we are all happy to help and practice. The more you write prods, the better you will get at them and the less you will see these errors. All right, so I think that is going to be all for SI today. On next Tuesday, we will program that calculator. So it's going to use input, it's going to use arithmetic. So that will be kind of fun. And yeah, thank you guys so much for coming.